Last time I was wondering how to look for a word into a base64 encoded file. Of course, I could simply decode the whole files and look for that word. But that's not what I really wanted to do. In fact, I was wondering how to look for a word in a file containing a base64 encoded text. Let me introduce Bob, as he will be our main protagonist here. Without any introduction, notice how this sentence is encoded into base64. Spaces have been underlined as they are not to be forgot. Now take a second to note that Bob has been encoded as QM9I. So now we don't need to decode the file anymore, and we can just grep for that text into that file directly. Let's encode another simple sentence, then try to find the base64 encoded version of Bob, which would be QM9I, no? Now we will go a little bit deeper into base64. Quoting Wikipedia, base64 is a group of binary-to-text encoding schemes that represent binary data in sequences of 24 bits that can be represented by 4 6-bit digits. Let's assume that each character is 1 byte long. According to previous definition, we would encode the 3 first characters together, then the 3 next ones, and so on and on. Here, we are looking for Bob. We can see that there are 3 cases. One with Bob fitting into a single 3-character chunk, 2 with Bob split into 2 3-character chunks. Without going into too many details, to decode or encode into base64, we will need to create a table with 64 rows. Each row will associate a letter to a 6-bit value. The 64 letters can vary according to the specific table used, but will mostly be the 26 uppercase letters followed by the 26 lowercase letters, so 52, then the 10 digits, so 62, then finally 2 letters to reach 64 letters. Now, let's focus again on Bob and explain how Bob becomes QM9I. First, we convert each letter into its decimal representation, then into its binary representation. In the end, we get 3 times 8 bits, and we put those 24 bits into a table. Please mind the change of color scheme as we go from this split to the 4 times 6 split required by base64. Now, for each of these 6 bits values, we extract from the table on the side the corresponding letter. And if everything goes as planned, we'll get the so expected result. We just finished one case in which Bob is not split into chunks. Now, let's do one of the other cases. We will start with the down left one. Note that we have now 2 subcases, one with the start and one with the end of Bob. We will do them independently, then we'll concatenate the results we will get. The first character can be anything, so we don't know its decimal representation nor its binary representation. But let's proceed anyway into the 24-bit table. The first chunk contains only unknown bits, so it contains no information about Bob, and we can just discard it. The second chunk is mixed with some unknown bits and some bits coming from Bob, so we can't process it directly. As you can see, the last 2 chunks are processed as before. Going back to the second chunk, 2 bits are unknown, but we can still match the last 4 bits characters of the base64 table. So we get 4 possible characters as we have 2 bits to play with. Now we are halfway in our second case as we need to process the next 3 characters chunk. We process as usual, but this time we don't know about the last 2 characters as they don't belong to the word we are looking for. So, characters to decimal to binary representation. We fill the table with the 24 bits we obtained. Then we act on each 4 6-bit chunks. The first one is easy, the second one is a mixed one, and the last ones are useless as they don't contain any bit coming from Bob. This time, the 4 rightmost bits are unknown, so we will obtain 16 consecutive characters. Let's sum up what we found for our second case, as we have now all the information needed. We get a nice regex we can use to find Bob encoded as base64. And finally, we reach case 3. As you already know everything there is to know about the issue at hand, let's listen to some elevator music.